Theorem. To prove that limit x goes to 0, a raised x minus 1 divided by x is equal to natural log of a, where a is greater than 0 and not equal to 1. Proof. Since x goes to 0, so a raised x minus 1 divided by x also tends to 0 by 0 form. Thus, we can't apply the limit directly. For that purpose, we let a to the power x minus 1 is equal to y, or a raised x is equal to 1 plus y. As when x goes to 0, then y also tends to 0. Since a raised x is equal to 1 plus y, so here in the given limit we need the value of x. So for that purpose we are taking the log of both sides. So taking log of both sides, we have log of a raised x to the base a is equal to log of 1 plus y to the base a. Now, according to the property of logarithm, we can bring the exponent x to the coefficient of the log. That is, log of x to the power y to the base a can be written as y log of x to the base a. So using this property, we can write this equation as x log of a to the base a is equal to log of 1 plus y to the base a. Now here we will apply the property of logarithm that log of a to the base a is equal to 1. So this equation becomes x is equal to log of 1 plus y to the base a. Therefore, the given limit x goes to 0, a raised x minus 1 divided by x can be transformed to the new variable, that is, limit y goes to 0, y upon log of 1 plus y to the base a. Here we have replaced a raised x minus 1 by y, while x by log of 1 plus y to the base a. Now we need to bring this y into the denominator. So this becomes limit y goes to 0, 1 divided by 1 upon y log of 1 plus y to the base a. Now again we will use this property of logarithm to take 1 upon y into the exponent of 1 plus y. So using this property, we have y goes to 0, 1 upon log of 1 plus y raised 1 upon y to the base a. Now applying the limit, we have 1 upon log of limit y goes to 0, 1 plus y raised 1 upon y to the base a. Now here we will apply the limit as limit x goes to 0, 1 plus x raised 1 upon x is equal to e, the Euler constant. So our relation becomes 1 upon log of e to the base a. Now this property of logarithm, 1 over log of y to the base x can be written as log of x to the base y, allows us to write 1 upon log of e to the base a as log of a to the base e. And we know that when the base of the logarithm is the Euler constant e, then we write it as ln of a. Thus, we have proved that limit x goes to 0, a raised x minus 1 upon x is equal to natural log of the constant, that is a. Hence, the theorem is proved.